ठीक है, just 1 minute. ठीक है, चलो ठीक है। राफे, आवाज आ रही है मिनाहिर?
Yes, yes.
अच्छा राफे, मैं तुम्हारा तुमने क्वेश्चन पूछा था, जस्ट वो मैं बताता हूँ थोड़ी देर में, ठीक है? मैंने भी
Okay.
देखा नहीं है। अच्छा, anyway, so let's start with this one. उससे क्या है, which gas has the first one? ठीक है, let's do it as quickly as possible. Rate of diffusion किन दो चीजों पे डिपेंड करता है?
Temperature and molar mass.
ठीक है, तो अब वो कह रहे हैं कि स्लोएस्ट का मतलब है इट्स गोइंग टू बी हेवीएस्ट और लाइटेस्ट?
Heaviest.
Heaviest.
Heavy.
ठीक है, तो आप जाके इनकी एमआर वगैरह चेक कर लो, एंड दैट वुड probably be carbon dioxide, क्योंकि ऑक्सीजन इज 16 एंड कार्बन इज 12। ठीक है, तो H2 जो होता है वो तो सबसे फास्टेस्ट होगा, तो hence the answer is going to be D. Next is chromatography experiment is carried out to analyze the pigments present in 4 different types of leaf. The student carrying out the experiment forgot to complete the table of results, which is shown. ठीक है, अच्छा एक काम करो कि आप लोग ना वो यूज करो, म्यूट कर लो, स्पेस बार करोगे ना तो उससे आपका म्यूट माइक ऑफ वो जो होगा वो ऑन हो जाएगा ऑटोमेटिकली स्पेस बार से। तो वो कॉन्स्टेंटली माइक ऑन होगा ना तो फिर वो बीच में इंटरफेरेंस आ रही होगी, जब जब कुछ कहना होगा ना तो बस आप वो स्पेस बार दबाओ तो माइक ऑन हो जाएगा। अच्छा, एनीवेज दिस वन, तो उससे क्या है कि द स्टूडेंट कैरिंग आउट द एक्सपेरिमेंट forgot to complete his table of results which is shown. तो F और G जो है ना वो उसने नहीं किए। अच्छा, which row identifies the value of F, G and H? तो first thing, F is the number of pigments identified. तो maple plant था, उसे color of identified pigments green and yellow. उसे distance traveled तो दोनों का distance 3 और 3.1 था, और RF value भी calculate. तो how many pigments does it have? मतलब it's
Two.
ठीक है, it's pretty obvious कि F की value क्या होगी, it's going to be 2. G के distance traveled by the solvent front. तो ये अब ट्रिकी पार्ट है कि हाउ वुड यू कैलकुलेट G? RF वैल्यू उसने कैलकुलेट करके दी हुई है, मुझे बताओ कि RF वैल्यू का फॉर्मूला क्या होता है? व्हाट इज RF वैल्यू? कोई आइडिया किसी को?
Distance traveled by solvent, dye divided by solvent.
ठीक है, डाई का डिस्टेंस डिवाइड बाय सॉल्वेंट का डिस्टेंस, राइट? तो RF वैल्यू आपके पास है, अब हमने G फिगर आउट करना है कि व्हाट इज G। तो मैं लेट्स से ये ग्रीन डाई की ना RF वैल्यू उसने दी हुई है, इट्स गिवन एज, नहीं उसने डिस्टेंस ट्रैवल दिया हुआ है ग्रीन डाई का। तो अगर मैं ग्रीन डाई की और मैं इसकी बात करूं, ये जो लॉरेल उससे दिया हुआ ना, ठीक है, वी टॉकिंग अबाउट दैट वन। तो इन दैट केस, ठीक है, वी हैव द RF वैल्यू ऑफ द ग्रीन डाई, ठीक है। सो लेट्स फोकस ऑन, या आप उसके साथ भी करोगे ना, येलो डाई के साथ, यू विल गेट द सेम आंसर। तो वी गोना यूज द ग्रीन डाई। RF वैल्यू ग्रीन डाई की कितनी कैलकुलेट की, इट्स गिवन इट एज 0.78, राइट? अच्छा, फिर उसने कहा है कि डाई ने डिस्टेंस ट्रैवल बाय द फ्रॉम द ओरिजिन बाय ईच ऑफ द पिगमेंट। तो ग्रीन ने कितना पिगमेंट डिस्टेंस ट्रैवल किया? 2.5। सॉल्वेंट ने कितना ट्रैवल किया वो हमने, वी डोंट नो व्हाट दैट इज, ठीक है। तो उसको हम x ले लेंगे, तो x की वैल्यू वुड कम आउट टू बी 2.5 डिवाइड बाय 0. If you rearrange that, it's going to be 2.5 divided by 0.78. Can anyone tell me what the value is?
3.2.
3.2.
अच्छा, 3.2 आ रही है, ठीक है। So this one is 3.2. And remember, if you had done it with yellow dye or yellow dye की RF value, you would have gotten the same answer as well. In both, in this case, both dyes are traveling exactly the same distance. So next one is H. Where is H? H is the RF value. ठीक है, RF value of the yellow dye. तो formula क्या होगा yellow dye का? It's distance traveled by the yellow dye, which is 3, and you're going to divide that by the distance that is traveled by the solvent, which is 3.5. तो क्या, what's the answer for that?
0.857.
तो you're getting 0.857, तो कोई आंसर ही नहीं है। Sorry, 886.86, right? So it's going to be, these are your, it's option C. Okay. So is this clear?
Yes, sir.
Next one. Which statement about isotopes is correct? First thing, quickly tell me what's an isotope?
Atoms of the same element having same number of protons but different number of neutrons.
Okay, so they have the same protons, but they're basically the same element. Protons, if the protons, remember, elements are identified by their proton numbers. Okay, every, like, if you have carbon, then all the atoms of carbon in the whole world, they all have 6 protons. But the number of neutrons, they can be different. Okay, uh, they can always be different. Neutrons don't really matter that much. Neutrons don't do anything. They don't have any charge. The other way to phrase this is that they have the same atomic number, but they have different nucleon number. Okay, so it's the different number of nucleons. I say anyway, so they have, which one is the correct answer in this case?
D.
Okay, they have the same number of electrons in the outer shell. Exactly. So they have the same protons, they have the same number of electrons. Nucleons are different because they are the same element, they have the same chemical properties, and they all have the same number of protons. So in the chromatography, which label represents the solvent front? A, B, C, D. Which one is the solvent front?
Say A.
Okay, it's A. Okay, remember, that's the solvent starts traveling up, the paper starts soaking the solvent, and the top point is the place where the solvent reaches. Different methods of separation rely on substances having different properties. So how does distillation work? Based on what property?
Boiling point.
Okay, so they have different boiling points. One boils first, condenses at the other end. The other boils later, condenses again at a later point. I said the arrangement of electrons in two ions formed from elements X and Y are shown. So which equation represents the reaction between the elements X and Y? As a first thing, you have to, I mean, you can quickly identify what the two elements are. For that, you would need let me just quickly open a periodic table. Just 1 second. So here's my periodic table. Remember, elements are identified by the protons. So you've got potassium at 19, and you've got where's chlorine? Chlorine at 17. So one is group 1, the other one is group 7. So this one is potassium, 19 protons. This one is chlorine. So the first thing is, do you know which one of them is diatomic?
Chlorine.
You can remember the entire group 7, your hydrogens and oxygen and nitrogen, they're all, if they're atoms, they're all diatomic. So Y would exist in the form of Y2. So which means it's either going to be C or it's going to be D. Potassium would obviously exist as an atom, right? Uh, so potassium is group 1. How many electrons would it lose?
1.
So X would lose 1 electron. It's going to have a charge of K plus 1. So X would have a charge of plus 1. And Cl is in group 7, so it's going to have a charge of minus 1. So it's going to be minus 1. So that's your equation. And this loses 1 electron, this gains 1 electron. So the ratio should be the same. If there are 2 X's, there should be 2 Y's. So that's the only correct equation. And remember, Y was diatomic. Next is which to identifies compounds that contain single covalent bonds only, double covalent bonds only, or both single. So C2H4, can you figure out how to draw the structure of C2H4? How many? Remember, you should be able to know how to draw structural formulas. How many bonds does carbon make? I mean, you've got 4 TK, you've got 2 carbons, and you've got 4 H's, right? So I'm trying to draw the structure of C2H4. So hydrogen makes only 1 bond. This hydrogen only makes 1 bond. Hydrogen makes 1 bond, right? Carbon is supposed to make 4 bonds. So that means there should be a double bond. Only then would carbon be able to make 4 bonds, right? So that means C2H4 has double bonds as well as both single bonds and double bonds. So C2H4 should come over here, right? Is this clear?
Yes.
Yes.
And that would probably make it C as the answer, but we'll do the other ones. Single covalent bonds only, CH3OH. So that's an alcohol. So you've got C, you've got O, and all single bonds. Carbon makes 4 bonds, so there would be 4 bonds over here. Oxygen makes, how many bonds does oxygen make? It's in group 6.
The two.
It makes only 2 bonds. So there would be H's everywhere. All of them would be single bonds. So remember this fact that a group 7 element usually makes 1 bond. A group 6 element needs 2 electrons. It usually makes 2 bonds. A group 5 element like nitrogen and phosphorus, they make normally they make 3 bonds. And a group 4 element, they always make 4 covalent bonds. This is about covalent bonding. So, and what's the name of this molecule? It's an,
Methanoic acid.
no, it's not methanoic acid. Huh?
Methanol.
Okay, this one is methanol, right? So this one is methanol. Meth is 1 carbon atom. And carbon dioxide is only going to have double bonds because carbon makes 4 bonds. So you have carbon and 2 oxygens. So it's going to make 2 bonds with this one, 2 bonds with this oxygen. So it's going to be 2 double bonds. So it will only have double covalent bonds. Next is, what's next? That you have ethyl methanoate burns in excess oxygen to produce carbon dioxide and water. The equation is shown what is the value of X. So how would you balance this? How many oxygens do you have on the right side? Can you count how many oxygens you have?
18.
So you've got 6 into 2, that's so you've got 18 oxygens. So how many oxygens do you already have over here? That's
4.
4. So 18 में से 4 निकालो तो you're left with 14. So X should be 7, right? Is this clear?
Yes.
Yes.
Acha, next one. One second. Just 1 second. So next one, rubidium is in group 1 of the periodic table and bromine is in group 7. So rubidium reacts with bromine to form an ionic compound. So he's saying what change is taking place for rubidium. Rubidium is in group 1. So what does it do? Lose electron, gain electron.
Lose.
TK and loses exactly it's going to be C or D. Would it form +1 or -1?
+1.
TK, so it's obviously +1, so it's going to be C. Next one is which statement explains why graphite is used as a lubricant. So what's going on with graphite? Why is it used as a lubricant?
Layers can slide over each other.
Okay, so remember just a quick revision of the structure. 1 second. Of graphite. So you've got sheets of graphite. Carbon in graphite makes 3 bonds. It's supposed to make 4 bonds, but it's making 3 bonds. The 4th electron is conducting electricity. So graphite is a very good conductor of electricity. Plus, it's a sheet-like structure, so there are multiple sheets lying on top of one another. So the sheets have weak intermolecular forces. The sheets can easily slide over one another, so they are used as lubricants, and they're very soft compared to diamond, which is very, 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 very strong. The next one, so layers in the structure can slide over each other. The next one is the relative atomic mass of chlorine is 35.5. When calculating the relative atomic mass, which particle is the mass of a chlorine atom compared to?
An atom of carbon.
So it's C.
Okay, so it's going to be C, carbon. Okay, all atoms. Remember, whenever you measure anything, actually, you always measure it against something. Okay, for example, if you want to measure length, some people measure it with feet, with relative to feet, like it's 1 foot, 2 foot, 3 foot, or so on. So there's always, you have to take something as a reference point. So for measuring the mass of atoms, it's always carbon 12. And universal indicator solution is added to a neutral solution of concentrated aqueous aqueous NaOH. As the first thing, universal indicator. Do you know how many colors it has? You have, I mean, you have to remember the strong acid. You've got weak acid. Then you have neutral solutions. Then you have weak base, and then lastly you have a strong base. So this is, let's say, pH 0. The middle part, neutral part, is pH equal to 7, and the strongly basic part is pH equal to 14. Can anyone tell me what's the color of universal indicator at in neutral conditions?
So green.
Okay, so that is green. And then it starts turning red. Weak acid, it's orange or yellow, and then it starts turning red when you have a strong acid. And weak base, it turns blue or light blue, and then it turns dark purple. So if it's a very strong base. So universal indicator has 5 colors. It actually has more colors than that. It's a complete gradual shade. It goes from red to purple. I say anyway, so it's being added to a solution of aqueous sodium chloride. So sodium chloride is a salt, so that is a neutral solution. So it's going to be green initially, right? And then the solution, which contains H plus 1, Na plus 1, Cl minus 1, OH minus 1, is electrolyzed. Oh, it's an electrolysis question. And remember, it's concentrated. So what happens? Let's do electrolysis quickly. How many ions do you have? You've got quick electrolysis. You've got cathode. You've got anode, right? This is the negative part. This is the positive part. The Na plus 1, he's already listed the ions above. So it's Na plus 1, H plus 1 going to the cathode, and the Cl minus 1 and the OH minus 1, they're going to the anode. Who's going to gain electrons at cathode? Na plus 1 or H plus 1?
H plus 1.
Okay, so the one that's lower in the reactivity Cs. Remember your reactivity Cs. And the equation would be that it's going to be 2H plus 1 gaining. It's a diatomic molecule, so you have to double that. And it would form H2. Who's going to lose electrons at anode? Cl minus 1 or OH minus?
Cl minus 1.
Okay, so remember this. It's going to be Cl minus 1. Whenever it's concentrated, it's always Cl minus 1. And that's also diatomic, so you double that. It's going to form Cl2 and it would lose 2 electrons. So H is gone, Cl is gone. What's left in the solution? That's NaOH, right? Is that clear?
Yes, sir.
Yes.
So that basically means that your NaCl has now changed into, after electrolysis, has changed into NaOH. So is that an acid or a base?
Base.
Okay, so metal hydroxides, metal oxides, they are basic. So it's a base. Base can, what's the color? It's either going to be blue or purple. So it's going to turn from green to blue purple, right? Which would make it C would be the right answer. The color changes from green to blue. Yeah. Okay. Is this clear? This question.
Yes.
Yes.
As the next one is let's move to the next one. What is the empirical formula of an oxide of iron formed by reacting 2.254 grams? इसको the side पे कर लेते हैं. So you've got 2.24 grams of Fe, and you've got 0.96 grams of oxygen. What's the first thing you have to do? You find the moles, divide by the AR, which is 56 in the case of Fe, and 16 in the case of its mass divided by the AR. So what do you get?
For Fe it is 0.04.
Okay, so for Fe it's 0.04. And for oxygen it's what?
0.06.
So you're getting 0.06. The next thing is you turn it into you find the moles, you turn it into the simplest whole number ratio by dividing by the smallest. So if you divide both by 0.04, what do you get?
1 ratio 1.5.
I said now 1 ratio 1.5, but again, that's still not a whole number ratio. So what should I multiply the two numbers with to get a whole number?
2.
2.
Okay, so it would become 2 and this would become 3, right? So it's 2:3. It's going to be Fe2 and O3. Okay, is that clear?
Yes.
Yes.
Acha, फिर next one. The combustion of methane is exothermic, so I think this is an energetics question. Which statement about the reaction is correct? So it's exothermic, right? Remember, in any reaction, you two things are happening. Old bonds are broken. I mean, you have to break the old bonds, like the oxygen-oxygen bonds and the carbon and hydrogen bonds. They need to be broken. And in the next step, new bonds are formed, right? Which step is endothermic? Which step is exothermic? So there's step 1, there's step 2, right? So which one is exo? Which one is endo?
Step 1 is
Step
exo
1
and
is
step
endothermic.
Okay, so step 1 is endo. It takes, I mean, it requires energy. You need energy to break bonds. And step number 2 is exothermic.
Exothermic.
I said, now the thing is that if the overall reaction, I mean, this entire reaction, if it comes out to be exothermic, which in this case he's saying that the combustion of methane is exothermic, that means this step releases more energy compared to this step taking in energy. Okay, that's the idea, that less energy is taken in to break bonds and more energy is released when bonds are formed. So which is going to be your correct statement out of all of these? So less energy would be taken in to break bonds and more energy would be released when forming bonds. Only then would the reaction overall be exothermic.
B.
D.
Okay, so it's the energy needed to break the bonds in methane and oxygen is less than the energy released in making the bonds in carbon dioxide and water. So that is correct. So it's going to be B. Okay, is that clear?
Yes.
Yes.
As the next one is you've got hydrogen reacts with oxygen in a fuel cell. The reaction is exothermic again. And he's saying that 286 kilojoules of energy is released for every mole of water formed. So for, I mean, this every mole, that means 1 mole. That if you form 1 mole of water, 286 kilojoules of energy is going to be released. So the question now is which volume of hydrogen gas measured at room temperature and pressure would react with oxygen, which would release 7,000 joules of energy? So remember, he's saying that 286,000 joules of energy. I'm turning it into joules because he's using joules. So he's saying 286,000 joules of energy is released when 1 mole of water is formed, right? So use ratios. How many moles of water would be formed if you have 7,000 joules of energy being released? I mean, you can use that as x crisscross, and it would come out to be 7,000 divided by 286,000, right? So how many moles are we getting?
0.0244.
0 point कितना है?
0.0244.
So you found the moles of water, right? Is this clear? Okay, how did you find the moles of water?
Yes.
So you are getting 0.0244 moles of water. The next step is, what was he asking? He's asking which volume of hydrogen gas measured room temperature and pressure would react. So it's the same ratio. 2 waters are produced with 2 H2s, right? So if you're forming 0.0244 moles, the amount of H2 would be exactly the same because you have exactly the same mole ratio. Clear? And lastly, अगर इसका volume figure out करना है, how do you figure out the volume?
By multiplying the moles with 24.
Okay, so volume of gas would be just multiplied by 24 dm cube. Acha, now he's given both. So tell me what's the answer in dm cube?
587.
So we have that. That's C. 587 dm cube. So that's our answer. As the next one, which substance? So the question is, which substance does not require oxygen in order to produce energy? Now, most of the reactions that produce energy that are used as fuels, they usually burn in oxygen. I mean, what is coal? Coal is mostly carbon. It burns in oxygen and produces carbon dioxide. Same goes with hydrogen, which burns with oxygen and produces water. That's a test for hydrogen gas as well. It burns with a pop sound. What's natural gas? Well, what's the formula of natural gas?
Methane.
Methane,
CH4.
CH4, and that also burns with oxygen and produces carbon dioxide and H2O. So most of these organic substances, and including hydrogen, they burn with oxygen and they produce carbon dioxide, right? So how is energy produced from uranium?
By fusion reactions.
Not just by fusion and fission, uh, but also by, I mean, simply if you have a piece of uranium, it's going to be glowing, it's going to be radioactive, and it would be releasing a lot of radioactive particles, and that is the way it's going to release energy. So D is, it doesn't require any oxygen. So that's D. As the next one, you've got nitrogen. So remember about this radioactive substances. And radioactive substances, kind of the issue is that the nucleus has too many protons and neutrons in the nucleus. Like uranium has around 237 or 235. It's the nucleon number. So so the nucleus of the atom starts splitting up. It starts emitting these radioactive particles in the form of neutrons and protons and electrons, and in that way it decays. So that's how radioactive particles, they don't undergo chemical reactions. They just simply the nucleus just simply disintegrates. As the next one is, you've got nitrogen and hydrogen and can be converted into ammonia using a catalyst. What's the purpose of the catalyst? What does a catalyst do?
To increase the speed of reaction.
Okay, so I think that's B. How does it do that?
By decreasing the activation.
Energy.
Okay, lowers activation energy, and uh, so most reactions need energy at the start. And why do they need energy at the start? Because we just talked about that you have to break the old bonds first. Because if the old bonds are really strong, it would require some amount of energy to break those old bonds. So, which is why every reaction requires energy at the beginning. And if you can somehow decrease that energy, then the reaction would speed up. And it lowers activation energy. What other things about catalyst? It remains unchanged, does not uh, take part in the reaction itself. And plus, one more thing about this is that that there are two things.
It regenerated at the end of reaction.
But it remains unchanged. Yeah, even if they react, I mean, they usually do react, but at the end of the day, they turn back into the original form. But there's another thing about let's talk about kinetic particle theory as well. That what does a catalyst do? That, remember that it does not. There are two things. One is the frequency of collisions, like how many times are the particles colliding, right? And the other thing is the effectiveness or the successfulness of the collisions, like are the collisions successful or not. So what a catalyst does is that it increases the effectiveness. Like you have 100 collisions, but only 10 were successful. In 10 of them, the bonds were broken and new bonds were formed, right? And the rest were just the particles just bouncing around. What a catalyst would do is that it would make it easy to break bonds. So you're still going to have 100 collisions, but now 50 of them would undergo, the old bonds would be broken and new bonds would be formed, and a reaction would happen. So what a catalyst does is it does not increase the number of collisions. It simply just makes them more effective. So remember this point as well, related to kinetic particle theory. The next one is ammonia is produced in the Haber process. So what's the conditions for the Haber process?
सर
Iron is a
450
catalyst.
टेम्परेचर
ठीक है 450 टेम्परेचर भी आ गया वन मोर थिंग व्हाट्स द थर्ड कंडीशन
250 atm pressure.
ठीक है so it's 250 is fine anything between 100 and 500 is fine ठीक है I usually just write 200 but 250 is also fine so anyways these are the conditions and remember it's an exothermic reaction delta H is this one is an exothermic reaction where do you get so I'm just revising the Haber process where do you get nitrogen N2 where do you obtain it from
From
Pressure
fractional
distillation
distillation
of
of
air.
air.
TK exactly so you get it from liquid air fractional distillation where do you get H2
From breaking of petroleum.
cracking ठीक है cracking of petroleum cracking ही कहा था ना I think अच्छा cracking of petroleum plus there's another thing electrolysis of water and then you also get H2 but mainly it's cracking of oil that's where you get H2 अच्छा anyways this thing this question looks and he's already told you that the forward reaction is exothermic now this question looks to be about equilibrium so मुझे बताओ, if I want to send this reaction forward what condition should I do increase temperature decrease temperature it's an exothermic reaction
सर डिक्रीज
ठीक है अच्छा ठीक है exactly so you're going to decrease temperature right decreased temperature favors exothermic in higher temperature favors endothermic what about pressure more gas this side is less gas so how do I make it go forward more pressure less
सर
pressure
इंक्रीज द प्रेशर
चलो ठीक है we're
More
going to so you're going to have more pressure you're going to increase pressure right so increased pressure less gas moles I mean you're squeezing it you're compressing it so less gas mole side there's just two molecules over here so it's going to turn into less gas um, so those are two main things so you're going to decrease temperature you're going to get a higher yield what's the so why do you use 450 why not a lower temperature what's the reason for that
सर द रिएक्शन वुड बी टू स्लो
ठीक है exactly you're going to get more NH3 but you're going to get it after a very long time so it would be better you get less NH3 but you get it very quickly so that's why you don't decrease temperature that much and why don't you use a higher pressure why I mean why just 200 atmospheres why not 2000 atmospheres
It's
सर इट
costly.
विल बी रियली एक्सपेंसिव
ठीक है it's going to be really expensive hard to maintain 2000 atmospheres it's going to be dangerous as well so increasing pressure increases the yield of ammonia there's going to be more ammonia so that's wrong the first one is wrong increasing temperature decreases the yield of ammonia but speeds up the reaction is that correct
Yes.
ठीक है so increasing I mean we said that you should decrease temperature so increasing temperature would favor the opposite reaction so it would decrease the yield of ammonia but at a higher temperature you're going to get a faster reaction it's going to be faster so which is why you still use a kind of a higher temperature you don't just decrease temperature that much so B is correct and the others are then obviously going to be incorrect increasing the concentration of hydrogen and nitrogen would obviously make more ammonia so it would increase the yield of ammonia increasing the temperature would decrease the yield of ammonia so that's also wrong as anyways let's move on to the next one this is about the contact process so what type of reaction is this is it displacement neutralization oxidation or thermal decomposition any idea
Oxidation.
it is oxidation it's the gain of oxygen is oxidation so that is definitely oxidation ठीक है we can quickly revise what I mean this was the contact process this during the manufacture of sulfuric acids we can quickly revise that the first thing is you burn sulfur with oxygen to produce sulfur dioxide right that's the first thing what's the condition for this particular reaction this one is a reversible reaction this is reaction number 2 in the contact process you form sulfur dioxide that's one then you turn the sulfur dioxide into sulfur trioxide do you know what the conditions are for this reaction
सर वेनेडियम पेंटाऑक्साइड एज द कैटलिस्ट
ठीक है, टेम्परेचर क्या होता है?
450 degrees Celsius.
और यहाँ पे ना there's pressure. Do you use high pressure or not?
Sir, low pressure.
नहीं, but what's the pressure?
Sir, 1 to 2.
अच्छा, that's 1 to 2 atmosphere. So it's kind of a low pressure. और इसके अंदर भी वही है कि why और एंड में क्या होता है? What happens when SO3 is formed? What do you do with it? How do you make sulfuric acid?
Sir, react it with sulfuric acid to make oleum and then react with it. Mist of liquid, like make it sulfuric acid then.
ठीक है, H2S2O7 और उसको फिर ना you dilute it with that's oleum, and then you dilute it with water to form 2 molecules of H2SO4. Why don't you just mix it with water? What's wrong with SO3 mixing with water?
Sir, uncontrollable fast reaction would occur.
ठीक है, so it's going to be an explosive reaction and so that's not industrially suitable. और प्लस इसके अंदर वो इक्विलिब्रियम वाली बातें सारी अप्लाई होती हैं कि you should have used a higher pressure, right? Because a higher pressure would favor less gas mole side. But you don't use a high pressure क्योंकि 1 to 2 atmosphere पे उसकी yield वैसी बहुत ज़्यादा है, बहुत अच्छी है. So why make it more expensive? Plus, you should have used a lower temperature because this reaction is also exothermic. Exothermic reactions are favored by lower temperatures, so more forward reaction would happen. But you don't decrease the temperature that much because the reaction would slow down. So next one is, how do you figure out which element is reduced in this one? Charges पता होना चाहिए. Do you know what the charge in Fe is over here?
+2.
So plus 2.
ठीक है, क्योंकि SO4 is -2, so Fe must be +2. What's the charge on Cl? It's a neutral element, so
0.
ठीक है, so that's 0 obviously. Can you figure out? I mean, you can also figure out the individual charges. What's the charge on H? What's the charge on O? H
H
in
plus
+1, right?
plus
O क्या होता है compounds के अंदर? What's the charge on O in compounds?
-2.
ठीक है, so that is -2, right? और सल्फर का हमें नहीं पता. ठीक है, so we can call that X. So there are 2 H's, so that's +1 into 2. There's 4 oxygens, so that's -4 into 2. You add them up. Overall molecule is neutral, so you put it equal to 0. You solve for X. X comes out to be equal to +6, I think. So you can figure out the individual charges as well. इसके अंदर खैर there was no need for it that much. अच्छा, Fe, what's the charge on Fe over here? I mean, SO4 is -2. What's the charge on Fe?
+3.
ठीक है, so it's +3. There are 2 ways of doing that. One is that you can either take Fe as X, and you know SO4 is -2, right? So there are 2 Fe's, so that's 2X, and SO4 is -2, so that's -2 times 3, and the whole thing is neutral, so that's going to be equal to 0, and X would come out to be, if you solve this, it's going to come out to be equal to 3. But otherwise now you do the reverse of crisscross. 3 यहाँ पे है ना, so this must be +3, this is 2, this must be -2. As anyways, H and Cl. H is +1, Cl is -1. So that's obvious. So which of the elements is getting reduced?
Chlorine.
Chlorine.
ठीक है, reduce का मतलब है जिसका charge reduce हो रहा है. ठीक है, that's the one that's gaining electrons. So it's going to be A. As anyways, next one is, you have this reaction. Which statement describes there's this reaction. Which statement describes the role of aqueous hydrogen bromide? So what is HBr doing? It turns into Br -1. So what is it behaving as?
Spectator
Sir,
ion.
proton acceptor.
हाँ, मतलब remember proton, what's a proton? ठीक है, whenever they talk about the word proton is an H+1 ion. क्योंकि H के पास है, it had 1 electron and 1 proton, but +1 का मतलब है the electron is also gone, so it only has 1 proton. So whenever I mean, a proton is an H+1 ion. They both mean the same thing. So it lost an H+1, right? It had HBr had H+1, and over here it lost it. So it's a proton donor, it gave it to someone else. Who did it give the H+1 to? He gave that H+1 to NH3, so it became NH4 plus 1. Is this idea clear?
Yes, yes.
Achha, plus, what do you call a proton donor? What other name is given to that? And what's a proton donor, mother? What do you call it? Is it an acid or a base?
So acid.
Acid.
Okay, so remember, so HBr is behaving as an acid, and NH3 is behaving as a base because it's accepting a proton. Okay, so NH3 is a proton acceptor. It gained an H+1 ion, and the other one lost an H+1 ion. So always remember, proton simply means H+1. So you've got these three reactions. Which reaction is suitable for making a salt by precipitation? Now this is ionic precipitation. So when do you use ionic precipitation? For soluble salts or insoluble salts?
Insoluble salts.
Okay, so you make insoluble salts using ionic precipitation, and the method is, like, if I want to make any insoluble salt, what I'm going to do is, let's think of an insoluble salt like lead sulfate, right? And that's according to the solubility table. So all sulfates are soluble except for lead and calcium and strontium and barium, right? So 3, 4 apart from these, calcium is partially soluble, but barium, lead, silver, strontium, these 3, 4 are insoluble. So how would you make this salt? Ionic precipitation is, you're going to think of two compounds. One of them should contain lead ions because the salt has lead ions. The other one should contain sulfate ions. But the condition is that the two compounds, they must be soluble. So what can I add next to lead? I mean, what compound can I have of lead that can be soluble?
Lead nitrate.
ठीक है, so remember, ठीक है, all nitrates are soluble, so you make it a nitrate. Uh, what can I add? What positive ion can be attached to SO4 minus 2 so that it's a soluble sulfate?
Sulfuric acid.
So you can have sulfuric acid, you can add H+1, it would be H2SO4, or group 1. All group 1 compounds are soluble as well, so that's, you can make it Na2SO4, etc., right? So lots of options. For lead, I think nitrate is the only option, I guess, because most lead compounds are insoluble. For sulfate, you've got plenty of options. You could have H2SO4, you could have sodium sulfate, potassium sulfate, ammonium sulfate. I mean, you've got lots of compounds of sulfates. FeSO4, they're all soluble. Apart from 3, 4, most of them are soluble. So you're going to mix the two substances together. Because the two compounds are soluble, in a beaker, what would happen is that they would dissociate into their ions. The H+1 and SO4 minus 2, when you mix them in water, they would all the ions would get scattered, and the ions would then start mixing up and start combining with each other. And if lead and sulfate combine, they would form the insoluble lead sulfate, which would settle as a precipitate at the bottom because it is insoluble. Any of the other ions, even if they combine, they would still remain part of the solution because they are soluble. Like if H and NO3 combine, nitric acid is soluble, so nitric acid would still remain aqueous. So it doesn't really matter. So that's how you're going to form this salt. And the description is that you're going to mix the two together. You filter out the lead sulfate precipitate, and then you wash this precipitate with distilled water. I say anyway. So which one do you think ionic precipitation would work? Would it work in the first one?
Yes.
It's going to make, you can make lead iodide by mixing a compound that contains I-1 and a compound that contains lead, and both compounds must be soluble. So you're going to get the ions would mix up and they would form PbI2 in the solution. Similarly, the second one, can I make AgI in the same method? I'll think of a compound of silver which contains which is soluble. Think of a compound of I which is soluble. The ions would mix up in solution and they would combine, and Ag and I would combine to form AgI precipitate. So that's also true. And it's not going to work for the third one. So the third one, ionic precipitation, is not going to work because you're not making an insoluble salt. Is that clear?
Yes.
So it's not going to work for the third one. But also tell me what's the third one? What method of preparation would you use for the third one?
Displacement reaction.
But this this is called the displacement. I mean, this is usually called the displacement reaction.
Double dis
The ionic precipitation is known as a double displacement, but there's a specific word for this. It's I mean, the three methods of preparation. Okay? One of them is precipitation. Okay? The technical word is precipitation. Uh, the name of the method of preparation is this one is called excess method. Okay? And what you do in excess method is in excess method. Remember, first method precipitation. Precipitation is for insoluble salt from soluble reactants. Excess method is that when you make a soluble salt from an insoluble reactant. So what you're going to do in excess method is the method of preparation is going to be that copper oxide over here is insoluble. So you're going to take copper oxide, put a piece of copper oxide or a rock of or a crystal of copper oxide which is insoluble in the beaker, and you're going to add sulfuric acid. So H2SO4 would be added. Now, what you have to ensure is that copper oxide is in excess. So you're going to add, so the statement is that you're going to add an excess of copper oxide. So you're going to keep adding excess copper oxide. And you keep adding excess copper oxide so that you can ensure that all the sulfuric acid has reacted. So the copper oxide would react with sulfuric acid to form copper sulfate. So your solution would contain copper sulfate only. So you will keep adding copper oxide until the copper oxide reacts with all the sulfuric acid and turns into copper sulfate plus water. So, and how do you know that you've added excess of copper oxide? Until you see it lying at the bottom and there's no reaction happening. So that means you've added too much of copper oxide. So you have to add an excess of copper oxide just to ensure that every last molecule of sulfuric acid over here has reacted. And once that happens, the next step is you filter this out. You remove it because it's insoluble. You can remove it, so the solution would only contain copper sulfate now. Is that clear? And you can crystallize the solution. So is this clear? Excess method.
Yes.
So what's the third method of preparation?
Titration.
Okay, that one is titration. And let me also have the third method of preparation is titration. So you've got, so I'm just going to quickly revise all of these three methods just very, very quickly. The first one, right, that's, we talked about the excess method. So you have an insoluble reactant. And you make a soluble salt from it. So, and you can use any reaction. You can use metal plus acid reaction, so that would work as well. Because the metal is insoluble. As long as the salt is soluble, right? So what other methods what other reactions can you use for making a salt? I mean, you have a metal plus acid and you have a
Acid and alkali.
Okay. Now, in this case, you're not going to use an alkali, you're going to use an insoluble base because it has to be an insoluble reactant, right? Alkalis are all soluble bases, okay? So base plus acid, and it's going to produce salt plus H2O. So even in that, you can use excess method. What's the third one? You can use carbonate plus acid. And remember, the carbonate has to be an insoluble reactant. So you can use carbonate plus acid. And that would also produce salt plus water plus.
Carbon dioxide.
Carbon dioxide. And excess method, these are the three main reactions that you can use. So you can talk about any reaction, like as long as you have an insoluble reactant. For example, you've got MgCO3, and I'm trying to make reacting it with nitric acid or any acid, and it forms a soluble salt, which is magnesium nitrate. Plus, I think it would produce water and carbon dioxide. So this one is insoluble, so it's a solid. The others are all, the salt is soluble. So in any of these reactions, if the conditions are met, if you have a soluble salt and the reactant is insoluble, you can use excess method. And what you just have to do is you add an excess of the solid reactant. You're going to take HNO3. Okay, that's one of the reactants. And you're going to add excess of MgCO3. So MgCO3 is an insoluble solid, so that would be added. And you're going to add it in excess. And the purpose of adding it in excess is so that all the nitric acid reacts and it turns into magnesium nitrate. So the solution now contains your salt, plus all the acid in the solution has reacted. So you keep adding MgCO3, keep on adding MgCO3 until all the nitric acid has reacted and the MgCO3 is just lying at the bottom unreacted. And then you can simply filter it out at the end. And your solution would only contain the salt. And you can crystallize the salt. So is this clear?
Yes.
So ionic precipitation, we did ionic precipitation. What about titration? When do you use titration?
Acid and alkali.
Now remember, it's not specifically acid and alkali. It's when you for titration. Remember, it even for excess method, it depends on the state of the reactants and the products. So if you have insoluble reactant and the salt is soluble, you use excess method, right? Titration is used when you have soluble reactants. So all the reactants are soluble. And the salt is also soluble. So that's when titration can be used. Now, this thing could be applied to any reaction. It could be, you can talk about base plus acid. I mean, you can call it alkali because all of them would be soluble. Any soluble base is called an alkali. So salt plus water. As long as this conditions are met, this condition is met, that you have soluble reactants and soluble salt. You can also apply titration to carbonate plus acid. And it would produce salt plus water plus. Plus carbon dioxide. You can also apply titration to another reaction, which is the reaction of aqueous ammonia with acid to form ammonium salts. Okay, so you can apply titration as long as this condition is met. You have soluble reactants and you have soluble salt that's forming. I left out just one reaction, which was the metal plus acid reaction, because the metal is always insoluble. So I ignored that because my reactant was supposed to be soluble and my salt was going to be soluble as well. So is this clear?
Yes.
Yes.
Okay, so just clarify that it's not just acid and alkali, in which case titration would be used. Titration could be used in any of the reactions that you've studied in which salts are produced, as long as this condition is met, that they're all soluble. So for example, we can take a carbonate, a soluble carbonate like sodium carbonate, right? And we can react it with HCl. So what would we produce? It would produce NaCl plus H2O plus CO2. Now, even for this reaction, you can use titration. and that's probably the only method that's going to work, because Na group 1 compounds are soluble, HCl is also soluble, NaCl is also soluble. All group 1 compounds, water is a liquid, CO2 is a gas. So what happens in titration? You take a burette, right? And you take a conical flask at the bottom. Okay? I can't draw a conical flask, but let's assume that's a conical flask. You put one of the reactants like Na2CO3 at the top. The other reactant is in the conical flask at the bottom. Okay? You use a pipette to transfer 25 cm cube of HCl into the flask. You fill the burette with Na2CO3, and you start adding Na2CO3 drop by drop. What happens? A reaction starts. Immediately when Na2CO3 reacts with HCl, what happens? It turns into NaCl, water, and carbon dioxide, right? The carbon dioxide is going to escape. So it basically turns into NaCl and H2O. Is this clear?
Yes, sir.
Now, this is titration. Now, in titration, the problem is, how do you figure out that you've added enough of Na2CO3? Because the problem is that if you stop the titration early, then that means there's going to be HCl still present in the salt, because not all of the HCl has reacted, because you did not add enough Na2CO3. The second problem is that if you don't stop the titration early, then you would add, I mean, all the HCl must have reacted, and you're still pouring in Na2CO3. So there's going to be, the salt would still be contaminated by extra Na2CO3. So you've got to stop right at this point when enough Na2CO3 has been added that all the HCl has reacted, gotten converted into NaCl, and you haven't added extra Na2CO3. So you want to stop over here. So what do you add in this beaker to ensure that you are able to figure out the endpoint?
So the indicator.
Okay, you're going to add an indicator like methyl orange. Remember the colors of the indicator. Methyl orange is going to be red in acid. And if Na2CO3, which is kind of a weak base, it would turn yellow or orange yellow. So as soon as all the acid is gone, the indicator, like if the flask, all the acid is gone, the indicator would change color from red to yellow. That would indicate that you should stop now. Because if you don't stop, that means you're adding extra excess Na2CO3, which is not needed. So is this clear?
Yes.
So what's the other indicator apart from methyl orange?
Sir, phenolphthalein.
Okay, so you've got phenolphthalein, which is in acid, it's going to be colorless. If it becomes basic, it's going to turn purple. So as soon as all the acid is gone, reacted, and you add one extra drop of Na2CO3, it's going to turn purple. That means that indicates stop the titration immediately. So if all of them are soluble, you use titration, because the problem is in excess it was easy, because even if you add too much of it, like you always add this solid in excess, you can always filter out the solid reactant. But in titration, because all of them are soluble, you can't do filtration. Like अगर आपने reactant को excess में डाल दिया ना, तो you can't just take it out. That's going to be very difficult. तो you have to ensure कि you don't add the reactant in excess. So which is why you add the indicator जो आपको बता रहा होगा कि नहीं अब रुक जाओ, ठीक है, अब आपने ज़रा डाल दिया. Clear है?
Yes.
Yes, sir.
Anyway, so that was a quick recap of the 3 methods of preparation. And सारों का याद रखना कि it's ionic precipitation is different. वो मैंने explain कर दिया था. Insoluble salt from soluble reactants, and I explained how to figure out the soluble reactants. कि आप वो salt को देखो, ठीक है, और उससे आइडिया लगा लो कि वो आपके 2 soluble reactants कौन से होंगे which are going to make this salt. Excess method कब होता है? When the reactant is insoluble and the salt is soluble. Titration कब होती है? When all of them are soluble. So next one is zinc oxide is an amphoteric oxide. Which row describes the reaction of zinc oxide? Alkali के साथ react करेगा, acid के साथ react करेगा, किसके साथ करेगा?
तो दोनों के साथ.
ठीक है, वो करेगा दोनों के साथ. तो it's going to be A. अच्छा ये वो कह रहे कि अच्छा इसको फिर दोबारा से रिवाइज कर लेते हैं, ठीक है. Forget the question. सॉल्ट प्रिपरेशन, वो कह रहा है he's trying to prepare pure magnesium sulfate crystals. अब MgSO4 के ना crystals फॉर्म करने हैं. मुझे बताओ कि what could be the reactions in which this salt could be produced? मतलब कौन सा एसिड यूज करना चाहिए?
Sulfuric acid.
ठीक है, वो SO4 से हिंट ले लो. It's going to be H2SO4 that's going to make this salt. अच्छा, now you've got multiple options. You can use a metal plus acid reaction. तो metal कौन सा यूज होगा?
Magnesium.
अच्छा, it's going to be magnesium. तो Mg metal plus acid produces salt plus H2, right? अच्छा, दूसरा और क्या रिएक्शन हो सकता है? MgSO4 बनाना है तो बेस प्लस एसिड भी हो सकता है. एसिड तो वही होगा H2SO4, राइट? बेस कौन सी होगी? मेटल ऑक्साइड, मेटल हाइड्रोक्साइड, कौन सा यूज करोगे आप? मतलब
Metal oxide.
ठीक है, मतलब Mg का यूज करोगे, या तो MgO कर लो या MgOH2 कर लो. दैट्स द सेम एंड इट्स गोइंग टू प्रोड्यूस वाटर, राइट? द थर्ड वन इज के MgSO4 बनाना है तो वही एसिड यूज करो, H2SO4. The third reaction of salts is carbonate plus acid. Carbonate कौन सा होगा? It's going to be MgCO3. तो वो साथ बना देगा water और साथ ही carbon dioxide भी. Is that clear? कि you have got three reactions that are going to produce MgSO4. Clear है?
Yes, sir.
Yes.
अच्छा, और तीनों के अंदर MgSO4 is a soluble salt, right? So soluble salts किस तरीके से बनाते हैं? आप बनाते हैं soluble salts या तो titration से या excess method से. It depends on the reactant. Mg insoluble, MgO insoluble, MgCO3 insoluble. तो जो मर्जी रिएक्शन चूज करोगे, the reactant is going to be insoluble. तो कौन सा मेथड होगा?
The titration.
Titration.
नहीं, टाइट्रेशन में सारे सॉल्युबल होते थे. टाइट्रेशन आप तब यूज करते थे कि जब रिएक्टेंट भी सॉल्युबल होते थे और सॉल्ट भी सॉल्युबल होती थी. नहीं सॉरी,
Excess.
ये एक्सेस मेथड आप तब यूज करते थे जब आपके पास you had insoluble reactant. Is that clear?
Yes.
Yes, sir.
अच्छा, so you've got these 3-4 reactions: metal plus acid, base plus acid, या जिसको आप alkali plus acid भी कह दो. ठीक है, मैं बेस और alkali में कोई खास फर्क नहीं होता, except कि alkalis are soluble bases. ठीक है, अगर बेस पानी में dissolve कर जाती है, so it's an alkali. So anyways, you've got these 3-4 reactions, right? जो सॉल्ट बनाते हैं, मेटल प्लस एसिड, बेस प्लस एसिड और कार्बोनेट प्लस एसिड. और एक चौथा रिएक्शन है जो कि ये अमोनियम सॉल्ट्स का है, जो कि हमने यहाँ पे किया था कि अगर अमोनियम सॉल्ट बनानी है ना तो अमोनिया प्लस एसिड होता है. ठीक है, सो दैट्स द फोर्थ रिएक्शन जो सॉल्ट प्रिपरेशन में यूज हो सकता है. एनीवे, सो यू गोइंग टू यूज एक्सेस मेथड, और वो यही कर रहा है. वो मेरे ख्याल से इज चोजन द थर्ड वन. उसने कहा है कि मैग्नीशियम सल्फेट के क्रिस्टल्स बनाने, तो मैग्नीशियम कार्बोनेट को पकड़ो और उसको डाल दो सल्फ्यूरिक एसिड में. सो इज यूजिंग द थर्ड वन. सॉलिड जो इनसॉल्युबल रिएक्टेंट है उसको आप एक्सेस में डालोगे, आप उसको डालते रहोगे जब तक सारा सल्फ्यूरिक एसिड डज नॉट रिएक्ट, राइट? इज दैट क्लियर?
Yes.
और फिर एट द एंड ऑफ द डे आपके सोल्यूशन में क्या पड़ा होगा? सिर्फ वो जो सॉल्ट, वाटर और कार्बन डाइऑक्साइड. कार्बन डाइऑक्साइड तो वैसी हवा में उड़ जाएगी. तो आपका जो सोल्यूशन होगा ना, मतलब ऑल द सल्फ्यूरिक एसिड वुड रिएक्ट और वो बना देगा MgSO4 और H2O. और आप ऊपर से ना MgCO3 डाली जा रहे होगे, फजूल में डाली जा रहे होगे, जब तक वो एंड में ना इट रिमेन्स इन अनडिसॉल्व्ड एट द बॉटम. ठीक है, एक्सेस में पड़ा होगा. तो उसको फिर आप क्या करोगे? उसको आप फिल्टर आउट कर दोगे, क्योंकि वो इनसॉल्युबल है. यू कैन इजीली, इट्स अ सॉलिड, यू कैन इजीली फिल्टर इट आउट. तो उसे क्या, विच प्रोसेस इज यूज्ड इन द नेक्स्ट? उसे क्या, ही एड्स मैग्नीशियम कार्बोनेट अंटिल नो मोर रिएक्ट्स, मतलब वो डाली जा रहा है मैग्नीशियम कार्बोनेट, और फिर उसको क्या करना है, उसको एक्सेस में जब डल जाएगा ना, यू विल जस्ट फिल्टर इट आउट. तो इट्स गोइंग टू बी C. इज दिस क्लियर?
Yes.
अच्छा, so this is going to be C, right? कि फिल्ट्रेशन करोगे और फिर आपका जो सोल्यूशन होगा ना उसके अंदर there's only one thing which is salt and water. तो वाटर को evaporate करो, crystallize करो, you'll get the crystals of the salt. अच्छा, next one, which row about elements? अच्छा, which row about elements in the periodic table is correct? Two elements in the same group have similar chemical properties. Is that correct?
Yes.
ठीक है, same group में ना they always have the same chemical properties. What do they have common if they are in the same period?
Valence electrons.
नहीं,
Number of
valence
shells.
number of shells.
shells.
हाँ
Yes,
ठीक है.
these are the-
ग्रुप में आउटर शेल इलेक्ट्रॉन सेम होते हैं, वैलेंस इलेक्ट्रॉन सेम होते हैं. पीरियड में दे हैव द सेम नंबर ऑफ शेल्स, तो इसलिए तो पहली दो में से कोई होगा. अच्छा, स्टेटमेंट नंबर 2 अबाउट द प्योर टेबल के मेटल्स आर ऑन द लेफ्ट ऑफ द टेबल, इज दैट करेक्ट?
Yes, sir.
correct.
ठीक है, so that's it's going to be A. अच्छा, next one, 26. You've got a new element कोई discover हुआ है, following properties. So it's insoluble in water, doesn't conduct electricity. The formula of the element is it's diatomic actually, ठीक है, OX2. और यहाँ पे वो कितने bonds बना रहा है? I think it's making a triple bond, right? तो अभी मैंने bonds का बताया था कि कौन कितने bonds बनाता है. कौन से group में होगा? By just looking at the number of bonds it's making.
Group 5.
ठीक है, तो मैंने बताया था ग्रुप 7 एक बॉन्ड बनाता है, ग्रुप 6 को 2 इलेक्ट्रॉन्स चाहिए होते हैं, मेक्स 2 bonds. 5 makes 3 bonds, so it's going to be group 5. And it doesn't conduct, so it's obviously a non-metal, right? So, so by just looking at the number of bonds it's making, that's going to be group 5. As a next one, a flammable gas needs to be removed from a tank at an industrial plant for safety reasons, and inert gas is used. Which अच्छा, वो बस कह रहे हैं which gas is suitable, तो कौन सी गैस inert है?
Sir,
Argon.
ठीक है, तो noble gas, argon. Transition elements can have variable oxidation states. मुझे बताओ और क्या properties होती हैं transition metals की? There are 5 properties in total, तो क्या क्या होती हैं?
Sir,
Colored
They act as a catalyst.
तो
They
catalyst,
have
color,
colored compounds. They have
अच्छा,
colored compounds. They have high densities and high melting and boiling points.
हाई मेल्टिंग पॉइंट्स, ठीक है, हाई डेंसिटी, हाँ ठीक है, सारे हो गए. एक तो उसने खुद ही लिख दिया है, हाई डेंसिटी, राइट? तो दीज आर ऑल द प्रॉपर्टीज ऑफ ट्रांजिशन मेटल्स. एक और प्रॉपर्टी जो कि ऑब्वियसली उस पर मार्क्स नहीं मिलेंगे, लेकिन वो होता है कि दे काइंड ऑफ अनरिएक्टिव. रिएक्टिविटीज में ना हमेशा थोड़े नीचे ही होते हैं वो. इसलिए आपको ना एवरीथिंग अराउंड यू दैट्स यूजुअली मेड आउट ऑफ मेटल्स दैट बिलोंग टू ट्रांजिशन मेटल्स, क्योंकि आयरन की जो कुर्सी है ना वो uh, एक दिन के अंदर किसी चीज का रिएक्ट नहीं करेगी. 10-15 साल ना उसे कुछ नहीं होगा. So which pair of compounds shows a transition element in two different oxidation states? चार्जेस पता करने हैं. सो बताओ कि what's the charge of chromium over here? ये क्रिस क्रॉस को उल्टा कर दो. तो 3 है,
Plus
तो यहाँ +3, राइट? ये 3 है, तो इसके ऊपर क्या होगा क्रोमियम पे? दैट्स गोइंग टू बी
plus
+3. तो यहाँ पे तो इट्स द सेम चार्ज, राइट? अच्छा, इधर भी वो कर लो कि ये कॉपर 2 ऑक्साइड, मतलब कॉपर 2 ऑक्साइड में व्हाट्स द चार्ज ऑन, मतलब O1 है, ठीक है, तो क्या क्या चार्ज होगा कॉपर पे?
+1.
ठीक है, इसमें
1.
भी +1 और ये -2 होगा, ठीक है. अच्छा, एनीवे, so this is +1. कॉपर कार्बोनेट में क्या होगा? व्हाट्स द चार्ज ऑन कार्बोनेट?
minus
Minus 2.
तो कॉपर पे +2 होगा, तो दैट्स B, ठीक है, कि इधर +1 है और यहाँ पे ना इट्स +2. अच्छा, 29. Which diagram best represents the structure of a substance that is a good conductor of electricity at 25? Good conductor of electricity at 25 डिग्री सेंटीग्रेड. तो पहले तो बताओ कि ये कौन सा स्ट्रक्चर है?
Diamond.
ठीक है, दैट्स इट डजंट कंडक्ट इलेक्ट्रिसिटी, राइट? ये कौन सा स्ट्रक्चर हो सकता है वैसे? गेस करो, वैसे कोई नाम बता दो किसी मॉलिक्यूल का.
NH3.
ठीक है, मतलब 3 बॉन्ड्स बना रहा है तो NH3, दैट्स फाइन, ठीक है, मतलब वो हो सकता है, दैट्स अ पॉसिबिलिटी. और कोवलेंट मॉलिक्यूल्स होते हैं, दे डोंट कंडक्ट इलेक्ट्रिसिटी, राइट? ये कौन सा, ये कंडक्ट करेगा इलेक्ट्रिसिटी?
No.
कभी भी नहीं करेगा.
No. करेगा जब molten या aqueous state में होगा.
ठीक है, बट नॉट एट 25, क्योंकि आयनिक कंपाउंड्स के अंदर मेल्टिंग बॉइलिंग पॉइंट्स काफी हाई होते हैं, तो उनको मोल्टन स्टेट में लेके जाना, दैट्स इट रिक्वायर्स हायर टेम्परेचर्स. ये क्या चीज है? कौन सा स्ट्रक्चर है?
alloy.
ठीक है, दिस वन इज एन एलॉय. Alloys are stronger than metals क्योंकि they have different sized atoms, तो वो structure जो होता है that's kind of irregular and they can't slip and slide over one another, ठीक है. अच्छा, एल्यूमिनियम is, पहले बताओ एल्यूमिनियम अनरिएक्टिव क्यों होता है? बल्कि क्या आंसर होगा?
Because it has oxide layer.
ठीक है, covered with an oxide layer which makes it unreactive, ठीक है. With the oxide layer is non-porous and tough, doesn't break easily. आयरन का रस्ट होता है, लेकिन वो बहुत easily ना, you can powder बन के you can easily take it off. Aluminium layer is kind of really tough, unreactive, non-porous. Aluminium की अगला क्वेश्चन भी एल्यूमिनियम पे, क्या क्या प्रॉपर्टीज होती है एल्यूमिनियम की? यूजेस बताओ एल्यूमिनियम के।
It has low density.
ठीक है, लो डेंसिटी तो कहाँ पे यूज होता है एल्यूमिनियम?
Airplanes.
ठीक है, मेक एयरप्लेन्स आउट ऑफ इट। सेकंड प्रॉपर्टी बताओ कि और क्या
It
Good
प्रॉपर्टी?
conducts electricity.
तो इसलिए वो हाई वोल्टेज ट्रांसमिशन वगैरह के अंदर एंड कंडक्ट्स इलेक्ट्रिसिटी वेरी वेल, क्योंकि एल्यूमिनियम लूजेस 3 इलेक्ट्रॉन्स, +3 होता है, सो इट हैज अ लॉट ऑफ डीलोकलाइज्ड इलेक्ट्रॉन्स, इट्स अ वेरी वेरी गुड कंडक्टर ऑफ इलेक्ट्रिसिटी, मतलब बाकियों से भी ज्यादा अच्छी इलेक्ट्रिसिटी कंडक्ट करता है। तीसरी प्रॉपर्टी बेस्ड ऑन यूज बताओ बेस्ड ऑन दिस के, अच्छा नहीं उसी के ऊपर, इट कंडक्ट्स इलेक्ट्रिसिटी राइट because it has a lot of delocalized electrons. But it also conducts heat very well, which is why it's also used to make pans. ये आपका baking pans or foils or aluminum foils. These are frequently made from aluminum क्योंकि it's a very good conductor of electricity as well. और फिर आखिरी जो है कि वो unreactive है, it's got a layer of oxide on it. तो ये food containers वगैरह ना इसलिए उससे बनाते हैं कि the food will not, जब आप कुक भी करोगे ना, it's not going to react. या उसको स्टोर करोगे तो टिन कैन, मतलब टिन कैन्स भी बहुत सारे एल्यूमिनियम से बने होते हैं, तो वो भी एक रीजन है कि इट्स काइंड ऑफ अनरिएक्टिव राइट। अच्छा खैर ये आ गया उसका बॉक्साइट का आ गया, तो ही इज ऑलरेडी गिवन यू व्हाट्स क्रायोलाइट।
The catalyst for this reaction.
Point.
it's not the catalyst, ठीक है, it's not the catalyst, it's an essential thing। फॉर्मूला पता है किसी को क्रायोलाइट? व्हाट्स क्रायोलाइट?
Cr
नहीं वैसे इट्स Na3AlF6। जस्ट यू शुड रिमेंबर दिस कि कहीं अगर लिखा हुआ आ गया ना तो कंफ्यूज ना हो जाना, ठीक है। इट्स Na3AlF6, दैट इज व्हाट क्रायोलाइट इज, एंड द पर्पस ऑफ दैट इज, किसी ने भी बोला भी था कि इट्स इट डिक्रीजेस द,
Lowers the melting point.
ठीक है एग्जैक्टली, लोअर्स द मेल्टिंग पॉइंट एंड हेल्प्स टू डिसॉल्व, क्योंकि अगर एल्यूमिनियम ऑक्साइड जो है ना मेल्ट नहीं हुआ ना तो क्या होगा कि वो इलेक्ट्रिसिटी कंडक्ट नहीं करेगा, उसके आयंस इधर उधर मूव ही नहीं कर सकेंगे। सो यू वांट टू मेल्ट इट। नॉर्मल कंडीशंस में इसका जो मेल्टिंग पॉइंट है दैट्स क्लोज टू 2000 डिग्री सेंटीग्रेड, बट विद क्रायोलाइट यू कैन डू द रिएक्शन, यू कैन मेल्ट इट एट 950 डिग्री सेंटीग्रेड। तो ये जो रिएक्शन है ना 2000 से कम होकर 950 पे आ जाता है। अच्छा कौन से आयंस हैं सोल्यूशन के अंदर? you've got Al+3 राइट, एंड you've got O-2। कैथोड पे कौन सा अट्रैक्ट होगा, और विच वन इज द कैथोड?
Aluminum.
ठीक है, कैथोड पे एल्यूमिनियम, और रिमेंबर ये जो आपका कंटेनर है ना दैट्स योर कैथोड, नेगेटिव टर्मिनल उसी के साथ अटैच्ड है। तो कैथोड पे जाके Aluminium+3 would gain electrons to form aluminium back again, ठीक है। सो दैट्स व्हाट्स गोइंग टू हैपन। एनोड पे कौन अट्रैक्ट होगा, ये जो एनोड बना हुआ है दी, जो, अच्छा तो ऑक्सीजन और डायटोमिक है तो 2I-2 would lose total of 4 electrons to, सब कुछ डबल हो जाएगा O2 बनाने के लिए, ठीक है। अच्छा लेकिन अब मुझे बता कि एनोड के ऊपर एक तो ये तो हो गया ना, ये मेरे ख्याल से इट्स गोइंग टू बी ऑप्शन बी राइट। तो मुझे तो एनोड पे और कौन से रिएक्शंस हो रहे हैं? डू यू नो ऑफ एनी अदर रिएक्शन दैट्स हैपनिंग एट एनोड?
carbon dioxide is produced.
ठीक है, क्योंकि एनोड्स जो है ना दे मेड फ्रॉम कार्बन, तो बिकॉज ऑफ द हाई टेम्परेचर्स 950 द कार्बन एनोड्स, ये जो पीसेज है ना ये ग्राफाइट के बने होते हैं, ठीक है, कार्बन के, that starts to burn and it would produce carbon dioxide, might also produce carbon monoxide depending के oxygen supply है कि नहीं है। So the anode needs to be replaced over and over again। और इसमें ये भी याद रखो कि कुछ और चीजें भी प्रोड्यूस हो सकती हैं कि क्रायोलाइट से ना यू गेट फ्लोरीन एज वेल, देयर इज F-1 आयंस, वो भी पॉजिटिव के साथ अट्रैक्ट होते हैं। So they would also lose diatomic and lose electrons to form fluorine as well, right? So that's also a possibility। एक क्वेश्चन के अंदर ना पास पेपर के अंदर उन्होंने एक्चुअली ये इक्वेशन भी लिखी थी, उन्होंने बताया, उन्होंने पूछा था कि भाई ये कहाँ से आई है, फ्लोरीन कहाँ से आई है। तो that's why although normally questions के अंदर you don't talk about fluorine, but remember कि fluorine can also be produced at the anode, और वो उन्होंने पूछा हुआ एक पेपर के अंदर। तो ये याद रखा कि एक पेपर के अंदर उन्होंने सारा पूछा था, लेकिन वो थ्योरी का क्वेश्चन था। एमसीक्यूज में भी आ सकता है वैसे कि ऑक्सीजन गैस प्रोड्यूस होती है, मेनली ऑक्सीजन गैस प्रोड्यूस होती है, लेकिन वो बर्न करता है तो कार्बन डाइऑक्साइड प्रोड्यूस हो जाती है, कार्बन मोनोक्साइड भी उससे प्रोड्यूस हो जाती है। and plus you also might get fluorine gas. Next 32 तो टेस्ट है effect of heat on solid S. नहीं ये क्या है effect of heat? अच्छा ये नीचे रिजल्ट दिया हुआ शायद. Brown gas given off together with a gas which relights a glowing experiment. कौन सी gas है?
Oxygen.
Oxygen,
अच्छा ऑक्सीजन गैस. ब्राउन गैस कौन सी होती है?
bromine,
ठीक है मतलब ब्रोमीन वाकई में रेड ब्राउन होती है. एक और बताओ ब्रोमीन के अलावा बताओ, क्योंकि ब्रोमीन तो यहाँ पे कहीं भी नहीं दिया हुआ ना, तो ब्रोमीन को तो निकाल ही दो, ऑप्शंस में ब्रोमीन है ही नहीं. और क्या ब्राउन होती है? ये याद रखना है कि इट्स NO2 इज ब्राउन. ठीक है, इज दैट क्लियर? कि नाइट्रोजन डाइऑक्साइड दैट्स अ ब्राउन गैस. So you have to remember that. Make sure you remember that कि NO2 is a brown gas. तो उधर से ना you would figure out that it must be a nitrate. ठीक है, so it's either A or D. क्योंकि a nitrate, like if you have a nitrate, it decomposes when you heat it, and it forms an oxide. Plus, it would form NO2. Plus, it's going to form O2 as well. Is that clear?
yes,
I said so NO2 gas is going to be produced. So it's either going to be aluminum nitrate or zinc nitrate. तो बाकी he's given other test. NaOH और ammonia डाला है. Both cases you got a white precipitate, and both cases it's soluble in excess. तो किस आयन का, जिंक का या एल्यूमिनियम का, किसके precipitates are soluble?
Zinc.
ठीक है,
zinc,
so zinc के precipitates, remember that they are both soluble. ठीक है, remember to memorize the tests. So it's zinc nitrate. तो इसलिए ना ये I think it was very important that you should know कि NO2 is a brown gas. ठीक है, mark that, क्योंकि वरना आप जिंक सल्फेट भी कर सकते थे. अच्छा, anyway, so there's your carbon cycle. What are processes P? P क्या है?
respiration,
ठीक है, what's Q? Carbon dioxide plants में जा रहा है.
photosynthesis,
Plants से मीथेन बन रहा है. What's R?
decomposition,
ठीक है, that's decomposition. Dead methane का process ये होता है कि decay of dead vegetable matter. That's how methane is formed. As 34 element sulfur is found in a number of different minerals. Which mineral contains the greatest percentage by mass of sulfur? वो बैठ के calculate कर लो कि sulfur की mass divide by पूरे की mass, which is Ba और S और 4 oxygens. ठीक है, तो percentage निकालते जाओ, मतलब 100 से मल्टीप्लाई करने की जरूरत नहीं है. You just keep doing that. ठीक है, you can figure out कि which one will have the greatest mass. वैसे अगर तुक्का लगाना हो जल्दी में तो किसको लगाओगे?
फिर D को.
ठीक है, मेरा भी अंदाजा D है. कैलकुलेट कर लेना, लेकिन इट्स गोइंग टू बी Fe is 56, सल्फर इज 32 + 32, तो इसके अंदर दिस मॉलिक्यूल हैज अ लॉट ऑफ सल्फर. इसके अंदर कैल्शियम इज 40, सल्फर इज 32, एक ही सल्फर है, 4 ऑक्सीजन्स भी हैं. So the amount of sulfur relative to all the other substances, that's kind of less, not that much. और lead जो है वो तो है ही बहुत ज़्यादा, that's around 207. Barium भी बहुत ज़्यादा होता है, that's 137. तो उसका मतलब है कि मॉलिक्यूल के अंदर सल्फर की mass would be very less. So देख के पता लग रहा है कि it's probably going to be D. But you can do your calculations. Which structure represents a molecule of ethanol? कौन सा ethanol? एक ही alcohol है, which
C,
C, ठीक है. Alcohols में there's OH, and this one is a carboxylic acid. This is ethanoic acid. This is ethene. This is ethane. So 36. Which structures are which are isomers of each other?
So 1 and 3.
1 and 3.
अच्छा, remember why not 3 and 2?
तो
Yeah,
ब्रांच एंड पे आइसोमर नहीं होते.
क्या नहीं होते?
ब्रांच एंड पे आइसोमर्स नहीं होते.
ठीक है,
but-
exactly. But basically आप इसको कह सकते हो कि bent. I mean, these two are exactly the same thing.
Yes.
क्योंकि आपने ना what you did was you just एक साइड से ना उसको बेंड कर दिया नीचे की तरफ. I mean that's not an isomer, it's the same thing. Isomer और ये भी वही है. आपने मॉलिक्यूल का ना you just painted, ठीक है, उसको बस टेढ़ा कर दिया. That's not an isomer. Isomer has to be that the bonds have to be broken and they have to be rearranged in a different way. So it's not just 1 and 3, 2 and 3 भी isomer है, क्योंकि ये सारे तो हैं ही एक, but they're the same molecule. 1, 2 and 4 are exactly the same molecules. उन तीनों में कोई फर्क ही नहीं है. They're exactly the same thing. So 1 and 3 का ऑप्शन दिया हुआ था, लेकिन if they had just tricked you कि 4 and 3 were isomers as well, ठीक है, और 2 and 3 were isomers as well. As anyways, which molecule is not produced by addition reaction of ethene? So ethene is this one. कितने addition reactions होते हैं ethene के?
4.
नहीं, first one bromination होता है. bromination में क्या होता है? You get double bond खत्म होता है बीच में, और इधर भी bromine ऐड हो जाता है, इधर भी bromine ऐड हो जाता है, ठीक है, and the double bond goes away or it turns into a single bond. So you're going to get B, right? It's going to be CH2Br, and this is also CH2Br. So B is correct. उससे not लिखा हुआ है, ठीक है. So we're looking for the wrong one. अच्छा, और इसके अलावा कौन सा होता है कि you've got this one. डबल बॉन्ड के ऊपर और कौन सी चीजें ऐड हो सकती हैं apart from bromine?
Hydrogen.
So you can have hydrogenation. So double bond बीच में single bond में convert हो जाएगा, H2 ऐड हो जाएगा, ठीक है. So that's उसकी conditions क्या होती है? Nickel catalyst plus 200 degree centigrade, right? और उसमें फिर alkane बनेगा, CH3 ये भी CH3 है, this is also CH3. So the first one is also correct. और तीसरा कौन सा रिएक्शन है?
Steam.
अच्छा,
H2O.
ठीक है, वाटर के साथ 300 डिग्री सेंटीग्रेड टेम्परेचर, फॉस्फोरिक एसिड कैटलिस्ट एंड 60 एटमॉस्फेयर प्रेशर. तो उसमें एक जगह OH ऐड हो जाएगा, एक जगह पे H ऐड हो जाएगा. सो you'll get this one. It's going to be CH3 on one side and CH2 and OH on the other side. So it's going to form. So एंड में आखिरी ये गलत है कि 2 कार्बन एटम वाली चीज है. सो हाउ कैन यू मेक 3 कार्बन एटम थिंग? दैट वुड नॉट बी पॉसिबल. इन सारों की इंपॉर्टेंस बताओ कि व्हाट्स द इंपॉर्टेंस ऑफ ब्रोमिनेशन फॉर एल्कीन्स?
It convert the bromine colorless.
ठीक है, bromine gets decolorized. It's a test for identifying alkenes. बाकियों का खैर कोई इतनी इंपॉर्टेंस नहीं है. हाइड्रोजनेशन की क्या इंपॉर्टेंस है? एडिंग हाइड्रोजन.
Margarine is produced.
ठीक है, unsaturated vegetable oils are converted into margarine. As the next one, you've got substance X, fermentation. Fermentation में what is X? किसको ferment करते हैं?
Glucose.
ठीक है, so it's glucose that's fermented. और एथेनॉल को टर्न करें कार्बन डाइऑक्साइड, और ये क्या है? सब्सटेंस Z. तो कार्बन डाइऑक्साइड कब कन्वर्ट होता है? व्हेन यू बर्न इट, राइट?
Combustion.
सो दैट इज कंबशन. तो इसलिए ये हो गया. और कंबशन में क्या होता है? कार्बन डाइऑक्साइड में वाटर प्रोड्यूस होता है, और ऑब्वियसली कंबशन में हीट होती है, तो वाटर स्टीम के फॉर्म में होगा. सो इट्स गोइंग टू बी बी. क्लियर है?
Yes, sir.
Yes.
अच्छा, which statement about nylon and terylene is correct? अब इनमें बताओ कि कौन सा वाला जो है वो नायलॉन क्या होता है?
Polyamide.
ठीक है, that's a polyamide, ठीक है. and polyamides, and it's a synthetic polyamide. इससे फिशिंग नेट्स वगैरह बनते हैं. उसका जो मोनोमर होता है उसके अंदर क्या होता है कि उसके अंदर यू हैव अ डायमाइन, और साथ वाला जो मोनोमर होता है ना, और इस तरह के ढेर सारे होते हैं, दैट्स अ डाइकार्बोक्सिलिक एसिड. उसके दोनों साइड्स पे ना, तो बीच में से H और OH हट जाता है. इसका H रिमूव हो गया और इसका OH रिमूव हो गया, और वो दोनों आपस में ना एमाइड लिंक बना लेंगे. दिस इज योर एमाइड लिंक, पॉलीएमाइड. और वो फिर इधर साइड पे भी चलता रहेगा, वो उस साइड पे एक और मॉलिक्यूल होगा. इट जस्ट कीप्स ऑन रिपीटिंग, राइट? सो इट फॉर्म्स अ पॉलीएमाइड. पॉलीएमाइड्स में एक तो नायलॉन हो गया. नेशनल पॉलीएमाइड कौन सा होता है?
Protein.
ठीक है, that's प्रोटीन. अच्छा, व्हाट अबाउट टेरिलीन? व्हाट्स टेरिलीन?
Polyester.
ठीक है, दैट्स अ पॉलीएस्टर. उसमें क्या मोनोमर्स होते हैं? उसमें एक मोनोमर होता है जिसके वन इज अ डाइकार्बोक्सिलिक एसिड, जिस तरह ऊपर था. दूसरा मोनोमर क्या होता है?
OH.
ठीक है, दैट्स अ डायोल. कि उसके अंदर ना दोनों साइड्स पे OH होता है। सेम चीज होती है, इसका OH और H बीच में से चला जाता है, तो अच्छा OH और H चले गए एंड बीच में लिंकेज बन गई उनकी, दैट्स एन एस्टर लिंक। और वो साइड पे ना H इसका आगे चला गया, OH वो चलता रहेगा, ठीक है, एस्टर लिंक्स फॉर्म होते रहेंगे, सीडल बॉन्ड O and O is formed, which is why it's called a polyester. It's called many, poly means many, so it's a polyester, और तो कौन सी स्टेटमेंट, polyamide polyester, they don't contain the same linkage, that's wrong. uh, they're not made from serial bond C. Toluene is made from two different monomers. That is true. Polyamide is also made from two different monomers. Both of them are made from two different monomers. But D is the only one that's correct. Is that clear?
Yes.
अच्छा, ये इनमें से which one is a protein? Protein,
D.
remember, is a polyamide. अच्छा, so A में भी वैसे amide है और
Like
D में भी amide है. So one of them is, both of them are polyamides. तो how did you figure out कि D होगा?
बॉक्स के एक साइड पे C डबल बॉन्ड O होगा और एक NH होगा.
ठीक है, एग्जैक्टली. बोथ ऑफ देम आर पॉलीएमाइड्स. ये जो ऊपर वाला हमने बनाया था ना, ऊपर वाला वो हमने A बनाया था. A में ना वो जो आपका बॉक्स है ना, उसके दोनों साइड्स पे यू हैव सेम थिंग्स, NH NH, इसके दोनों साइड्स पे सीरियल बॉन्ड O, सीरियल बॉन्ड O. प्रोटीन्स में ना बॉक्स के दोनों साइड्स पे ना, बॉक्स वो मॉलिक्यूल होता है, ठीक है, इट कुड बी एनी मॉलिक्यूल, उसके ऑन बोथ साइड्स देयर डिफरेंट थिंग्स. व्हाई आर दे डिफरेंट? क्योंकि प्रोटीन का मोनोमर क्या होता है? व्हाट्स द मोनोमर ऑफ प्रोटीन?
अमीनो एसिड.
As an amino acid has, on one side it has carboxylic acid and on one side it has amine. Or proteins are made from a single monomer, which is amino acids. उसके अंदर दो different monomers नहीं, वही monomer repeat होगा, एक साइड पे NH NH और एक साइड पे डबल बॉन्ड और OH. तो एंड में वो OH और H हटेगा, बीच में एमाइड लिंकेज ही बनेगी. बट बॉक्स के ना एक साइड पे NH होगा, दूसरी साइड पे सीरियल बॉन्ड होगा. तो बड़ा स्लाइट सा, देयर इज अ वेरी स्लाइट एंड सटल डिफरेंस बिटवीन प्रोटीन्स व्हिच आर आल्सो पॉलीएमाइड्स and nylon which is also a polyamide. So just a very tiny subtle difference. तो ये याद रखना, ठीक है, just a minor point. बस मेरे ख्याल से पेपर खत्म हो गया. ठीक है, क्लियर है? कोई क्वेश्चन नहीं है? मुझे कोई अगर टॉपिक रिवाइज करना हो ना, कोई स्पेसिफिक, वो मुझे बता देना आप, ठीक है, ग्रुप के अंदर. चलिए ठीक है, लेट्स कंटिन्यू नेक्स्ट टाइम देन. ओके एवरीवन, टेक केयर, अल्लाह हाफिज.
Thank you, sir.
Thank you,
So
sir.
when is the next class?
जी,
Sir, when is the next class?
पता नहीं, एक दो कल तो रहने दो, फिर मैं बताता हूँ, ठीक है. ग्रुप पे मेरे से पूछ लेना, कल तो ऑब्वियसली प्रॉब्ली नॉट
sir.
पॉसिबल. चलिए ठीक है, आई विल टेल यू ऑन द
Thank-
ग्रुप, ठीक है. ओके, टेक केयर, अल्लाह हाफिज.